and I'm going to be going through the exam countdown from week 1 right through to week 30 with you. So I'm going to get started straight away. Today we're going to be doing order of operations, factors and multiples, number systems and thirds. So I'm just going to throw them up on the screen there so you have an idea of exactly what we're going to be covering in the next half an hour. Okay, so I've put them up on the screen there and I'm going to go through each of the 4 topics and I'm going to be giving a couple of examples. I'm going to work them out just as I'm going through them. So what I'd advise you to do is have a copy and a pencil in front of you to take down the examples as I go through them. Now I'd ask you as well to refer to the website, the countdown, so the Junior Cert Higher Level countdown. And as you complete the live lesson and each of the sets of notes, and there's additional videos, on the website as well, and you can tick them off as you complete them. So I'll get started with the order of operations there first. Okay, I'm going to get started with the order of operations first, and you might remember this from school. It's BIMDAS, okay? So BIMDAS, okay? So that's the word that you need to remember when you're thinking, what order should I complete a sum or an equation in? Now, I like to use the triangle, and the reason I like to use the triangle is because I think it's a clear representation of where everything goes. So B goes at the top, and B stands for brackets. So I'm just going to write this out alongside. So B stands for brackets. So they're always done first, and I'll show you again with an example. Then we have I for indices, okay? Indices, and I'll explain as I'm going through examples what they actually mean. Then we have M and D together. So we put M and D together, which is multiplication and division. And the reason you put multiplication and division together is because they get the same level of importance. And then finally we have addition and subtraction, so A and S. Okay, so M is multiplication. We have D, which is division. And A for addition. And then finally we have S for subtraction. So we need to keep this in mind. So that's the order that operations need to be done in. If you get an equation or a sum that has multiplication, division, subtraction, brackets, everything in it, you would always do it in this order. So brackets first, indices then. Indices are powers, so I'm going to go through that in a minute. M for multiplication, division next, addition next after that, and then subtraction is done very last. Now I was saying here, and you can see it in the triangle, that M and D are in the same category and A and S are in the same category. So you always would do this from left to right. I'll give you an example of this. So if you had 3 plus 4 take away 1, you would always read that from left to right, not right to left. Okay, so you would do your addition first. So 3 plus 4 is 7, 7 take away 1 is 6. So just keep that in mind. And I'm going to put a note in on that as well. So for M and D, which are together, multiplication and division, and A and S, so they are always read left to right, which is the way that you would do equations anyway. So that's BIMDAS, and we know now that what every letter represents. So I'm going to go through a couple of examples now to clarify what I'm after going through there. Okay, I'm going to get you to take down example 1 and I'm going to go through how to actually do it. So example 1 will be very straightforward. So it's going to be 8 multiplied by 11 plus 23. So 8 multiplied by 11 plus 23. So when we're looking at this, do we have any brackets? So we have no brackets, so that's what will be done first. So we don't have any brackets. I, which is indices, which is powers, so 2 squared, 3 squared, that kind of thing. There's no indices here, so we can leave that. Now, multiplication is done next. Do we have multiplication? Yes, we do. Okay, so I'm going to mark that in. That says multiplication. So that will be done first. We've no division. We have addition, and we don't have subtraction. So we're going to do the multiplication first, and then we're going to add in the division bit. Okay, because that's the order that it's done in. So 8 by 11 is 88. It's going to be 88 plus 23. And when you do that out, you get 111. Now, just for curiosity reasons, I'm going to show you what would happen if you didn't multiply first and you did it the other way. So 8 by 11 plus 23. So we'll say we did the adding bit first. So 11 plus 23 is 34, is going to give us 34. Now if you then multiply 8 by 34, you're going to get 272. And you can see there, that answer is not the same as that. And that's why it's really important to do it in order as BIMDAS shows, okay? So I'm just going to put a mark in that as well, that this is the wrong way to do it, and this is the right way to do it, because you're following BIMDAS, B-I-M-D-A-S. Okay, I'm going to give another 2 examples of that. So example 2. So I'm going to put in 50 divided by 10 plus 2. Now again, we're using BIMDAS. So do we have any brackets? We don't. Do we have any indices? We don't. There's nothing to the power there. Do we have any multiplication? We don't. Do we have any division? Yes, we do. So there's the division. That's going to be done first. Okay, so I'm just going to underline that. That's division to be done first. We do have addition, and the addition will be done then. So we're going to divide 50 by 10, and you're going to get 5, and then you bring down the 2. So 5 plus 2 is 7, and that's your answer for example 2. I'm going to give one more example there. I'm going to give a harder one this time. So example 3. So this one is going to be 98 divided by 3 plus 4 squared. Okay, so let's look at this. This time you've got brackets, okay, and we know that brackets is done first. So that's the bit we're going to do first, what's in the brackets. So I'm going to bring it down to the next line. So it's going to be 98 divided by, so 3 plus 4 is going to be 7 squared. Now to figure out what we do next. So we've dealt with the brackets, indices. So indices is something to the power, which we have here, 7 squared. So we can do that next. So it's going to be 98 divided by, so 7 squared is 49. And when you divide 98 by 49, you get 2. So that's the answer for example 3. Now what I'd advise you to do as well, if you go into exam focused junior cycle higher level, you can go into a video that has already been made there as well of the order of operations. So it's just a quick 8-minute video to revise what I'm after going through there. So it's just kind of extra material to go through. So we're moving on to the next topic now. The next topic is factors and multiples. Okay, so we're on to the second subtopic now, which is factors and multiples. And just to revise, you'll know this from covering the ordinary level material. So n is a set of natural numbers. So you really need to remember that. So it's a set of natural numbers. Now, what that means is that they're positive whole numbers. So we start at 1. We don't say that zeros is a natural number because it's not a positive whole number. It starts at 1. So 1, 2, 3, 4, and it goes all the way up to infinity, okay? So that's your set of natural numbers, and that's really, really important to remember what a natural number actually is. Now I'm going to go through the other 2 types of numbers that you have as well, and we'll be going back over this again when we go look at number systems. But we have Z, and Z stands for integers. And integers are positive and negative whole numbers, so positive and negative whole numbers. So you're talking, I'm just going to give an example. We say -5, -4, -3, -2, -1, 0, 1, 2, and so on. So they have to be positive and negative. They have to be whole numbers. So you couldn't have -1.5 or 2.3. It has to be a positive or negative whole number. So the next thing I want to explain is a factor, okay? And I'm going to use an example to explain this. So I'm going to put down example 1 again from section 2. So example 1. And I'm going to write down 4 by 5 equals 20. So that's a very simple equation, okay? Now, because when you multiply 4 by 5 you get 20, we say that 4 and 5 are factors of 20 because they both go into 20, okay? So I'm going to write that down. So 4 and 5 are factors of 20, which means that they both divide into 20. Now, if I wanted to look at 20, how would I describe 20? Well, we say that 20 is a multiple of 4 and 5, because when you multiply 4 by 5, you get 20. So I'm going to write that down as well. Okay, so we say 20 is a multiple of 4 and 5. I want to give another example now, so example 2. And if the question said, write down all the factors of 40. So what they're asking you to do there is to write down everything that divides into 40. Okay? So in order to do that, we would need to write down what multiplies to give you 40. So we know 1 by 40 gives us 40. We know 2 by 20 gives us 40. We know 4 by 10 gives us 40. We know 5 by 8 gives us 40. We know 8 by 5 gives us 40. And 10, 4 again. So they're all the factors. So the way we would list this, so the factors of 40 are 1, 2, now we'll list them in order. So 1, 2, 4, 5, 8, 10, 20, and 40. That's pretty straightforward. All you have to do is just write out everything that divides into 40 and you get your factors. Now the next thing under this category is prime numbers, and it's really, really important that you know what a prime number is. So prime numbers are natural numbers that have two factors only, itself and 1. I'm just going to write that out. So prime numbers are numbers that only have two factors. So only two things will divide into it. So only have two factors, itself and 1. Now an example of that would be the number 3, because 1 by 3 equals 3. We don't have anything else that divides into 3, only 1 and 3. Another example of that would be 7. 1 by 7 gives you 7. So the prime factors are 7 and 1. If we kept going, so the next prime number is going to be 11. 1 by 11, because they're the only factors that will actually divide into 11, 1 and 11. And one more, so we'll go 1 by 13 gives you 13. So they're all prime factors, okay? And I'm going to give an example now of how you would complete a question to do with prime numbers, especially at higher level. So this is example 4. And the example is to write the numbers (102) and 170 as a product of prime factors. So this is a real higher level question. Now, the way you're going to do this is you're going to look at 102 and you're going to look at 170, okay? So you're going to start by dividing the lowest prime number you have into both numbers. Now, the prime numbers, if we look, I usually list them. So 1 isn't a prime number, remember that. So 1 is not a prime number. Now, the next prime number you'd have would be 2, because it's only 2 by 1. The next prime number is 3. The next prime number after that is 5. The next prime number after that is 7. The next prime number after that is 11. The next prime number after that is 13. The next one after that is 17. And you can keep going, because all of those numbers only have two factors, itself and 1. So let's go back to the question for a minute. So look at 102 first. So the way you do this is you're going to look at the lowest, you're going to see does the lowest prime number divide into it. So you're going to divide 2 into 102. When you divide 2 into 102, you get 51. What you're going to do then is you're going to see does the lowest prime number divide into 51 again. So it doesn't. We know that 2 won't go into 51. So then what you're going to do is you're going to try the next prime number, which is 3. So does 3 go into 51? It does. So 3 into 51 goes 17 times. Now, there's still a remainder here. So we want to see, does any prime numbers, or do any prime numbers divide into 17? So will 2 go into 17? No. Will 3 go into 17? It won't. Will 5 go into 17? It won't. Will 7? No. Will 11 go into 17? No. Will 13 go into 17? No. We know that 17 will go into 17. So 17 into 17 goes once. And once you're left with a remainder of 1 at the end, or not a remainder, but it goes into it once, you know then that you're finished. Okay? So we write down then at this point that 102 is equal to 2 by 3 by 17. Okay, so I'm using these outside numbers. So 2 by 3 by 17 will give you 102. Now I'm going to go back and do the same thing with 170. Okay, I'm going to start with the lowest prime number, which is 2. So 2 into 170 goes 85 times. So now I'm going to try, will 2 go into 85? It won't. Will 3 go into 85? It won't. Will 5 go into 85? It will. So 5 into 85 is going to go 17 times. Now, same thing again here. We know that none of these numbers are going to go into 17 all the way up to 17. So none of those numbers will go into 17. So we know that the last one that's left is going to be 17 itself. So 17 into 17 goes once. And what we can write out now is that 170 is equal to 2 by 5 by 17. So now this is the key part where you have to find what's common to both. So we have a 2 here and we have a 2 here. We don't have a 3. Well, we have a 3 here, but we have no 3 here, so I'm not going to circle that. We have a 17 here and a 17 here, so I'm going to circle both of those. And then what you're going to write is that the product, or the product of the prime factors is going to be 2 by 17. So the common factors are 2 by 17. So the common factors, or the product of prime factors, is common factors, or with the product of prime factors, which is what you were asked for. You're going to multiply 2 by 17. And when you multiply 2 by 17, you get 34. And that's the answer. So there's a couple of examples of them in the exam papers as well. So I'd recommend that you try them and make sure that you're able to do those types of equations, because it's really important. They come up quite frequently. So I've spoken about natural numbers briefly and integers. So natural numbers, remember that are positive whole numbers. So example of natural numbers would be 1, 2, 3, 4, etc. all the way up to infinity. Integers is Z, so I've explained them as well. They're negative and positive whole numbers. So an example of that would be -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, and it goes on. Now, the other one that I hadn't mentioned yet was rational numbers. So rational numbers are denoted by the letter Q. So Q are rational numbers. And rational numbers is any number in the form A over B. Okay, so I'm going to write that down. So they're numbers in the form A over B, where A and B, they're an element of Z. Okay, so they're A and B are integers. Okay, so where A and B are integers, so it could be any of them. So A and B are integers. And the other thing as well is that B cannot be 0. So the bottom number, it cannot be 0. Okay, now an example of a rational number would be 2 over 3. Another example of a rational number would be 1 over 4. Okay, so it's a fraction we're talking about. Now remember as well that the bottom cannot be 0. Okay, so it can be an integer, but it cannot be 0. Okay, so example 1 from this section. I'm going to do an example to explain this a little bit better. So I'm going to draw what we call a Venn diagram. And I'm going to put N on the inner circle. Then I'm going to draw another circle and I'm going to put Z there. And then finally I'm going to put an outer circle and I'm going to put Q. So we know that n is natural numbers, z is integers, and q is rational numbers. So what I'm going to write down then is a series of numbers. Okay, so I'm going to put minus 1, 2 over 3, 4, 5, 7 eighths, minus 16, and minus 13. Now the question is to place each of these numbers into the correct part of the Venn diagram. Okay, so with that, I'm going to look at the first one. So the first one is minus 1. Okay, well, it's not going to be a natural number. Minus 1 is an integer, so I'm going to put minus 1 just here in this area where z is. So I'm going to put minus 1 there. Next number is 2 over 3. Now that's a rational number because it's a fraction a over b. So that's going to go in this section here where q is. So 2 over 3. Then we've got the number 4. That's a natural number. So that's going to go here. Number 5. That's also a natural number. So I'm going to put that there. 7 eighths is definitely a rational number. So I'm going to put 7 eighths here. Minus 16 is a integer, so I'm going to put that there, minus 16, and then minus 13 is also an integer, so I'm going to put that there. So that's pretty straightforward, you just have to know which category each of them go into. The last part of this particular section is irrational numbers. So I'm just going to write down what an irrational number is, okay? So an irrational number, it's a real number and it cannot be written as a ratio of integers. Okay, so that's the definition. I'm going to write out the definition and then explain it using an example. Okay, so an irrational number is a real number, and I'll get to real numbers in a minute as well. So it's a real number that can't be written as a ratio of integers. Now, for example, so a over b, like we had before, you cannot write it like that. Now, an example of that would be root 2. If you plugged in root 2 into your calculator, you'll get this number. You get 1.41421356237. Now that's a ridiculously long number. You would never be able to put that in fraction form. So basically, if you can't write a number as a fraction like this, it's an irrational number, and that's how you recognize it. Then we're on to real numbers, which I mentioned briefly there a minute ago. So real numbers, and this is the last one. And a real number is easy to remember. It's a number. A real number is a number, any number that can be represented on a number line. Okay, so a real number is any number that can be represented on a number line. Now I'll give an example of that. So an example of a real number would be minus 1.5, 2, 2.5. So just show you how I'd represent that on a number line. So if I just drew my number line here, and I'm going to put 0 in the middle, and I'm going to go back just in minus 1, minus 2, minus 3, and I'm going to go up 1, 2, 3. So if I was to show these numbers on a number line, minus 1.5 would be here, 2 would be here, and 2.5 would be there. So you can show them on a number line, which means that they're real. And the other thing as well is that real is donated by the letter capital R, and then irrational numbers we say is R over Q. Just if you see those again, you'll know what they mean. So the last thing I'm going to do in this section is thirds. So I'm going to go through the couple of laws that there are on thirds and examples to explain each one. So the first law is law 1. And law 1 is root A by root B is the same as saying root AB. Now an example of that. So root 8, that's the same as saying root 4 by root 2. Now if you get the value of root 4, the root of 4 is 2. So the answer is 2 root 2. Okay, I'll give another example of that. So root 18, that's the same as saying root 9 by root 2. Root 9 is 3, so 3 by root 2 is 3 root 2. So go on to the second law now. So the second law is root A over root B is the same as saying the root of A over B. And we'll do an example to show that now as well. So if we have root 100 over root 25, that's the same as saying root 100 over 25. So let's check, is that true? So root 100 is 10, root of 25 is 5, so 10 over 5 is 2. So that's that one. Now we'll check this side. The root of, so 100 divided by 25 is 4. Root 4 is 2, so that proves it. So we're going to go on to the third law now. So that's going to be root A by root A is equal to A. So for that one, root 4 by root 4 should give you 4. That's what that explains. So root 4 is 2, root 4 is 2, 2 by 2 does equal 4. So that proves law 3. So I'm going to do 2 more examples and they kind of be typical questions that you'd get in exam paper. So example 1, and the question is to reduce, which means simplify or break down. So reduce root 45 to its simplest third form. So reduce root 45 to its simplest third form. So the way we do that is we're going to find the largest square number that is a factor of 45. So the largest square number that is a factor of 45. So the answer to that is 9. 9 is the largest square factor of 45. So root 45 is going to be root 9 by 5. Okay, so we can rewrite that then as root 9 by root 5. Root 9 will give you 3, so 3 by root 5 is 3 root 5, and that's the answer to that one. So we'll give another one, so example 2. And this is to simplify. So simplify root 50 plus root 8 minus root 32. So to simplify that. And again, to do this, try and get the largest square number of all of these thirds. So is there any square number that will go into 50? So 25. So instead of writing root 50, let's write root 25, root 2, plus. So any number that will, or largest square number that will go into 8, so that's going to be root 4. So we're going to rewrite that as root 4, root 2. So rewrite that. And then finally, let's rewrite root 32. So take away any large square number that will go into 32, it's going to be 16. So it's going to be root 16, root 2. So can we simplify any of these? So root 25 is 5, so that's going to be 5 root 2 plus, so root of 4 is 2, so 2 root 2. Take away, so the root of 16 is 4 root 2. Now you'll see here, these are all root 2's. So if you have 5 root 2's and you add 2 root 2's, you're going to get 7 root 2. You take away 4 root 2, it's going to be 3 root 2, and that's the answer. So it just takes a bit of practice with these. The last example I'm going to do with you is an example that you see here. So simplify 1 over root 2. Now there's a rule here. When you see a third on the bottom as a denominator, the way you get rid of that third is to multiply everything by the denominator. Okay, so you're going to multiply the numerator and the denominator by whatever the denominator is. So I'm just going to put that rule in. So the method of eliminating a third from the denominator in order to simplify an expression is known as, we say that it's rationalising the denominator. So that means multiplying the top and the bottom by whatever the denominator is. So in this case, it would be 1 over root 2. And you're going to multiply the top and the bottom by root 2, because that's the denominator. Now when you do that, 1 by root 2 is going to be 1 root 2. Root 2 by root 2 is 2. So your answer is root 2 over 2. So that simplifies it. So that's it, guys, for this week. I will speak to you next week, and we're moving on to Algebra 1 next week. So I hope you found that useful, and I will speak to you next week.